Hey everybody, Mr. Kilgore here. Today we're gonna talk about scientific notation, everybody's favorite topic. I'd like to give a shout out to Mr. Gould for helping me out and looking over this with me. So thank you, Mr. Gould. So in this, we're going to learn how to convert regular numbers into scientific notation and scientific notation numbers into standard notation. We're going to review the exponents in base 10 and our language objectives. We are going to express numbers with their degrees of magnitude in scientific notation. So what is scientific notation anyway? Scientific notation is a way of representing a number with its power of 10. We're not doing any operations to the number. The number is going to be the same, just in a little bit different format. So this is the format of a number in scientific notation. Rather than in your standard format, we're putting in the number in a format of n times 10 to the p, where n is a number between 1 and 10, has to be less than 10, greater than or equal to 1, and p is an integer, a positive or negative whole number. Before we get started, why would we use scientific notation anyway? Well, in science, a lot of times we have very large and very small numbers. So it's a way of keeping track of the values, the place values. And it makes calculations really easy to work with. So take a look at this number. You can't even tell me how many zeros there are. You'd have to pause it, and then you're going to mess it up when you're counting. So that's the number of mole particles in a mole of hydrogen. Ironically, I'm recording this on Mole Day, October 23rd. Here's the mass of an electron. It's a really small mass. There's a lot of zeros. You couldn't even tell me that there were 33 zeros. Just kidding, there's 34. You didn't even know. See? That's why we use scientific notation. So check this out. Number of particles in 1 mole of hydrogen, 602, blah, 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 about half a trillion trillions. Really easy to put it in this format. 6.02 times 10 to the 23rd. We don't even have to worry about the number of particles in the standard format. Mass of an electron. A lot of zeros, 911 grams. Scientific notation, 9.11 times 10 to the negative 34 grams. Don't even worry about the standard notation. Use scientific notation. It's nice and easy. Exponent review, 10 to the third. You just take the product of 10 3 times. 10 times 10 times 10 is 1,000. 10 to the fifth, you take the product of 10 5 times. You get 100,000. Negative exponents are the 1 divided by 10 to the power, same power. So 10 to the third, we just talked about, is 1,000. 10 to the negative 3 is 1 divided by 10 to the third, or 1 over 1,000, which is 0.001, or 1,000. 10 to the 0 is 1. That's something you hopefully remember from algebra class, because that, fundamental idea here. All right, so moving on. Let's do a couple examples here. So 45,300, well, to put that number between 1 and 10, we move the decimal point between the 4 and the 5. So we get 4.53. To get that number equal, we multiply it by 10,000. So that's 4.53 times 10 to the 4. So why do we do this? To get 4.53 from 45,300, we're dividing by 10 to the 4th. So we need to multiply by 10 to the 4th. That's why the red number 4.53 is equal to 45,300 divided by 10,000. So that's why we get the 4.53 times 10 to the power of 4th. You're moving the decimal point over 4 times. So you got to multiply by 10 to the 4th. Really, what you're doing is multiplying the number by 1. And you can always multiply the number by 1. It's my second favorite number to multiply by. Y'all know my first. Here's an example of a decimal. So 0.000847 is, to put the number between 1 and 10, we make 8.47. Then we multiply it by 1/10,000th. So why? Because to get the number between 1 and 10, we're multiplying by 10 to the 4. We're moving the decimal point over 1, 2, 3, 4 times. So therefore, we have to multiply it by 10 to the negative 4. So we're not changing the number. So, and if you guys remember, 10 to the 4 times 10 to the negative 4 equals 10 to the 1. So we're multiplying by 1. So to put it in the format, 8.47, that's where the blue numbers come from. We're multiplying by 10 to the 4. So we have to multiply by 10 to the negative 4 to make it equal. Why? 10 to the 4 times 10 to the negative 4 equals 1. Putting a number in scientific notation does not change the sign of the number. A negative exponent is not the same as a negative number. We put a negative sign in front of the number to make it negative. So these are negative numbers because they have a negative sign in front of them. Here's a number less than -1. Here's a negative decimal. So that's why the power is negative. These are positive numbers because they're greater than 0. So you got 4,600 is 4.6 times 10 to the 3. You can have positive, negative exponents for positive decimals. That just means the negative exponent means it's a decimal. Do another video on this coming up. Okay, so let's do a couple examples. If you guys want to try, good time to pause here and watch and try yourself, and then we'll go over it. Otherwise, here we go. So first, let's put the number between 1 and 10. So this first one, we're going to move the decimal point right between the 1 and 2, right there. For this one, we're going to move it right between the 3 and the 8. And for the last one, we don't have to do anything. It's already between 1 and 10. So let's figure out the power of 10 now. How many places did we move the decimal point? So in this first one, we moved the decimal point 1, 2, 3, 4, 5 places. So we have to multiply by 10 to the 5. Here, we move the decimal point over 1, 2, 3, 4 places. It's a decimal, so we get our negative exponent. So it's 10 to the negative 4. Lastly, we didn't move the decimal point at all. So we're going to multiply by 10 to the 0. Nice and easy. All right. Let's do some converting into standard notation. So here we got a couple examples. If you guys want to try these right now, why don't you pause, take a second to give it a shot. All right. Otherwise, we're going to keep on going. So here we have 4.14 times 10 to the 5. You're just multiplying by 10 5 times. So you get 4.14, 6.7, 1.2. First one, you're multiplying by 10 to the 5 times, or 100,000. So you get 400. And this one, you're multiplying by 1/10,000th. This last one, you're multiplying by 1, because 10 to the 0 is 1. And here we go. Let's get those nice and easy. 414,000, 0.00067. And last one, 1.2. All right, guys, that's it. Got a couple other videos coming up. We'll do one on engineering notation, calculations using scientific notation as a tool, and everyone's favorite topic, the metric system.